Hello everyone, welcome to OVERMUGGED Sec 3 IP WA2 revision. So for the lesson today, we will be doing on kinematics and dynamics. So we'll do kinematics first, then dynamics. And I'm teacher Felicia. Yep, so I'm Miss Felicia. And let me give you a short introduction first before we start with the lesson, because I believe like quite a lot of y'all like do not know me, or maybe like your first time seeing me. Yep, so you can I give you the water during the middle of the lesson, because the water dispenser spoiled. So I need to give you bottled water. Unless you ask teacher planner to get for you. Okay, so so for the you break my phone, sorry, I cannot come back. Okay, so for Overmark, just to share a little bit with you all, in case like it's like your first time like hearing Overmark. So for Overmark, we are actually specialist tutors. So we actually specialize in teaching certain subjects. So we don't teach like every single subject. And when we teach that subject, we are actually really good in it. Yeah, and for Overmark, we actually have all range of tuition. We have like from science, we have math tuition, languages, even humanities tuition we also have from secondary school, Sec 1, all the way until JC. Yeah, until JC2. And we cover O levels, express stream, IP, as well as A levels. So for our teachers, we are all the very young teachers. So all of us are all like 30 plus year old or 20 plus year old, like won't be like the super old kind. Yeah, so that like we can click in with you all. Yeah. So then for Overmark, here are our branches. So right now, I'm actually at Bukit Timah branch, which is located beside the Tan Kah Kee MRT station. This is our west outlet. We also have an east outlet, which is at Marine Parade Parkway Center. And we also have a bit more centralized, a bit more northeast location at Kovan. Yeah, so these are the three branches of Overmark. But I think some of y'all may have heard of like Overmark. We do teach at other places. True, because we actually do rent like classroom spaces elsewhere. So these are not Overmark centers, but more of we rent classroom space. So we do have classes at these locations, but there's less. Yeah, so at the main Overmark centers, there will be more classes. And for IP tuition, we are only having it at the Bukit Timah branch, which is where I'm at right here. Yeah, that's why I'm teaching the IP classes. And a little bit introduction about I myself. So this is my name. I teach mainly the O-level stream and IP stream, but for this year, I only teach like the IP classes. And these are my track record from the past. And previously, I'm actually from NTU. I graduated from NTU and I majored in science. All this while, I have been teaching IP and O-level. I teach all three sciences for upper sec and lower sec. So from sec 1 to sec 4, Chem Biophysics. Before I joined Overmark, I was actually previously in the Learning Lab for 7 years. And even before Learning Lab, I was in another tuition center called Wisland. And back then, when I was like a uni student, I did a lot of like relief teaching at various MOE schools. Very long time ago, I also did like private tuition, but now I only teach at like tuition centers like at Overmark. So these are photos of my students. Yep. So for our lessons, we will incorporate like practical lessons, experiments. And for all students who sign up for tuition, we actually will give you a book of curated notes. These curated notes will actually consist of the first topic in Sec 3 all the way until the last topic in Sec 4. So even if like you join tuition midway, still okay, because you still have the notes for the earlier chapters. And for Overmark is a very welfare kind of place where we will as and when we order like food to treat our students, like koi, as you can see over here. And then we also like order like pizza, order like KFC. And on the this is like once in a while. Yeah. So for a regular basis, we actually have the free snack bar. Yeah. So we actually have an area where there are a lot of snacks where students can take every time when they come for class. Yeah. So that's Overmark. So for today, we will be going through mainly the notes first to go through the key concepts. Then we will practice the worksheets where we will be looking at like the common misconceptions, practice those questions that very commonly tested, and those that commonly tested, the more you should like score it, right? Because it's like you can prepare for it. And I'll be going through with you like what are the keywords needed for like the open-ended section. Yep, then we will try out the questions today. Yep, so let's begin. Okay, so for the first topic for today, it would be on kinematics. Here's a quick revision on kinematics. First, need to know that the quantities you learn in kinematics are classified into scalar or vector. For distance, it will be scalar because there is only magnitude, like how long you travel. So it's like 5 meters. Then without direction, that's distance. If you mention about the 5 meters and you say that the 5 meters is towards maybe like Bukit Timah or 5 meters towards the north, if you specify a direction, then it will become a vector quantity. So from distance, it will become displacement. That means distance and displacement, they are similar, just that one no direction, the other one has direction. Next, need to know how to do the calculation. For distance, it will be the entire path that you have traveled. But for displacement, it's only start to end. That's why it's mentioned over here that distance is the total length that you travel. It's the entire curvature here. As compared to displacement, you just check where is the start and where is the end. Then you draw a line that connect from the start to the end. The shortest distance would be this will be called as displacement. And since distance and displacement are similar, the units is in meter. By the way, just to take note that for my lesson, I'll write a lot of like highlighting, I'll write a lot of annotations. So you are supposed to follow me and highlight and annotate too. Okay, so that means whatever you see on my screen should be the same as your worksheet. So I take it that you should be done highlighting by now, because not much to highlight. Okay, so I shall move on. Next part over here on speed versus velocity. For speed, it would be the scalar version. So that's why if you look at the definition, it will be just the rate of change of the scalar, which is distance. So you always match same. Speed and distance, both scalar, as compared to velocity, which is vector. That's why your definition would be vector. Have to be same. Next, you see this word here, per unit, right? Need to know that in physics, per unit always means divided by. That's why if I were to ask you maybe what is the definition of density? If you didn't memorize, no worries, because density is this extra info. Okay, so density is the broken heart shape. Yeah, because density is M over V, mass over volume. Then can you see there is a heart shape? Then it's like broken heart shape. So once you remember what the formula is, you can come up with the definition already. Because definition of density would be mass. Instead of saying divided by, you say that it's mass per unit volume. That's why there's no need for you to memorize the definition of speed and velocity. Because once you know per unit means divided by, you just make the formula to become a sentence. Then that will be the definition already. Next, need to also take note that for speed versus velocity, if common kind of question they will ask, which is this is also one of the common misconception, I would say, among students. If your speed is constant, what do you think is the velocity? Can the velocity be constant? Or can the velocity be changing? Or can it be both? Do you have any idea? Yeah, it can be both. So take note, okay, that speed constant doesn't necessarily mean that velocity is constant. It can also be changing. Why? The reason is because of the direction. If your direction is constant, then the velocity is constant. If your direction is changing, even though the magnitude is constant, so you see, if my speed keep on is the same, maybe always 60 kilometer per hour. If my speed is constant at 60 kilometer per hour, but I keep driving left, right, up, down, like keep changing direction, then the velocity will be changing instead. Now I try to do the reverse. If my velocity is constant, what do you think will happen to the speed? Will the speed be constant or will the speed be changing or can it be both? Any idea? It should be constant, cannot be changing. Because once your velocity is constant, that means both direction and magnitude are constant. As velocity is actually a vector quantity. So both magnitude and direction will be constant. And since speed is only the magnitude, that's why the magnitude is constant, that means speed will be constant. Done. And the last part here, I think this one you all should know. So once you are done copying, then I'll move on. So for those online, once you are done copying, can you click the thumbs up reaction button to let me know? Then I'll move on. Yeah, so make sure you copy everything in. These are the common misconceptions, so need to know. So once you are done copying, can you click the thumbs up reaction button to let me know? If you can't click, then maybe you can type in the chat to let me know like the word done or just say done. Then I'll move on. So Kimberly, Angela, Adviata, and the person's nickname called Error, are you all done? Can I move on? Okay, I think I shall move on. Is Kimberly around? Is the person's nickname called Error? Are you around? Oh, okay. So like, are you all done copying? Like, is it okay if I move on? If you are still far from done, then maybe you want to take a screenshot for Error and Kimberly. If not, I move on already. Okay, so moving on. Next part. Need to know the difference between average speed versus instantaneous speed. Average, for example, if I were to ask, what's the average score of this whole class? To get the average score of this whole class, maybe for your WA1, what I'll need to do is I'll need to take the total score of all the students divided by the total number of students, correct? That's why whenever you see the word average, you must always think of total. That means one of the common misconception among students is that for the total time, some of my students, they will omit the rest time. Take note, if I say total, total will include everything. It includes the time that you're moving. It also includes the time that you stop. That's why I need to include everything because it's total. So please include the rest time also. That means the time when the person stop moving, you must count that duration too. So it really has to be total distance divided by total time. That's why for average speed, there will only be one value because the entire class only have one average score. So similarly to an object moving, there will only be one average speed. As compared to instantaneous speed, there will be many values because it depends on at that specific timing. When you look at the speedometer, what number it is, that would be the instantaneous speed. Next, acceleration. Acceleration is known as the rate of change of velocity. Likewise, need to know that whenever you see the word rate, rate means divided by time. If you were to divide by any other thing, like just now the density formula or the speed formula, yeah, if you were to divide by other thing, like maybe density is mass over volume, right? You divide by other thing, you use the word per unit. But once you divide by time, you should use the word rate. That's why acceleration, you see the denominator is divided by time, you use the word rate. And if I compare to over here speed, you all know that even from primary school is distance divided by time. That's why you see, once it's divided by time, you use the word rate. So rate is specifically only divided by time. If you want to divide by any other thing, you use the word per unit instead. Next, need to know the formula. Formula is A equals to V minus U over T. By now, I think you should know what this means, but I'll just write it down as a reminder. V is final, U is initial. Then for all of them, need to know the units. Speed is always meter per second. T is time, time is in seconds. A would be acceleration, acceleration will be ms minus 2. That's all that I'll be going through over here. So for those online, once you're done copying, can you click the thumbs up reaction button to let me know? Then I'll move on. Are you done? If done copying, can you click the thumbs up reaction button? Angela and Isabel, are you done? Okay, Isabel done. Angela done? Okay, let's move on. Next part over here is on average acceleration. This kind of question is seldom tested, but if they test, there is a specific way to solve it. Yeah, so this one you must like learn the skill from here. For this question, they show you a ticker tape timer and that they will pull it towards the right. So what is a ticker tape timer? It's actually a machine where they will keep on punch hole. Then there is like this long strip of paper, which we call it as a tape. So as you move, they will keep on punch, 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 punch. So based on the spacing, you can actually know the speed of the vehicle. Because if you pull fast versus you pull slow, the spacing between the dots will be different. First, let's analyze for this diagram. If you were to pull the strips to the right, are you able to tell which side is the start and which side is the end? So which is the first dot that gets punched first if you pull it to the right? Can tell? Yes, correct. The right side is actually the start and the left side is actually the end. Because if you have a nail over here, if you punch on the right, then you pull the strip towards the right, wouldn't the last dot that get punched hole, it would be the left side dot? And that's why how you read is you read from right to left instead. Next, for this question, they said that the diagram shows a strip of paper tape pulled under a vibrating arm by a trolley moving at a constant acceleration. The arm is vibrating regularly at a frequency of 40 Hz. This phrase over here, it means that they actually punch 40 dots in 1 second. Can you follow and copy it down? Punch 40 dots in 1 second. And now they are asking you for the average acceleration. When you see the word acceleration, I think immediately you know that you should use this formula, right? Because acceleration is v minus u over t. Now, let's see whether can we sub in all the values. I start off with maybe u first. U is initial. Initial means at the start, right? So over here, do I know what is the initial speed? Speed, the formula is distance over time, correct? Do I have the distance for the first section here? Yes, right. You see, I have 5 cm. But remember to convert it to the SI unit. So it would become 0.05 meter. So yep, I have the numerator 0.05 divided by the time. So how do I know what's the duration? Because it's not labeled. You have to use the frequency. How do we calculate the number of dots? Best method it would be you count the number of gaps instead. That means the number of dots, to know how many dots is it, you count the number of gaps instead. That means in this case, it will be 1 gap, 2 gap. That's why I will calculate it as 2 dots. So how do I know how much is 2 dots? Maybe I can find out 1 dot first. 1 dot would be 1 divided by 40. So you press calculator, 1 divided by 40, it will be 0.025 seconds. Then now you calculate for 2 dots. So 2 dots will be times 2, 0.05 seconds. That's how I can put it in my denominator. Okay, then next, if you're wondering like, how come like need to count as gaps? The reason is because for ticker tape timer, we always count the first dot as 0. So that's why this is considered as 2 dots. But to count the dots is a bit riskier because what if you forget to count as 0? Because you know normally when we count things like if I see maybe got a lot of apples, so I count 1 apple, 2 apple, 3 apple. I will start with 1 ma. Or if I have a lot of pen, so I count how many pen do I have? I have 1 pen, 2 pen, 3 pen. So we always start with 1. That's why we don't have a habit to start counting from 0. Best don't count the dot. You count the gap. When you count the gap, the number of gaps will match the number of dots. That's why you see 2 dots, 2 gaps. Yep, you can take it as 2 dots. So done for you. So you just press, okay, don't need press calculator. This one can mental sum. U will be 1. Next, for V would be final speed. Final means at the end. If you were to calculate what's the speed over here, same thing, it's distance over time. Distance, convert this to SI unit, it would be 0.02 meter. That's why your numerator is 0.02. For your time, in this case, how many dots are there? Same thing, you count the number of gaps instead. So 2 gaps means 2 dots. And 2 dots we have deduced earlier on, it's 0.05 seconds. Then now you press the calculator, you should get 0.4. So the value for V is 0.4. Last value would be time. How to know what's the time? Mainly is that because this is average. Whenever you see the word average, remember I told you it's always in terms of total. Yeah, and that for average, if you look at like maybe the average score of the class, it's also like the middle, right? Okay, maybe I write down as here. Right, if I say that if I take the total score of the class and I come up with the average score, isn't the average score is also the middle scoring students' marks is quite close. Yep, so what we can do is we go and find out where's the middle. For the first section, the middle is this dot here. For the last section, the middle is this dot. What you need to do is same thing, cause time is always based on the number of dots. How many dots are there from the purple to the purple ones? So same thing, you count the number of gaps. So it will be 1 gap, 2 gaps, 3 gaps. So if there are 3 gaps, it would be like 3 dots. That's why it will become 0.075 seconds. So now my new denominator will actually be 0.075. Yeah, so this is how you derive the time. So I would say that the most difficult part out of this whole section here, it would be to derive the time. Yeah, because how to derive the time? Because average is like the center. That's why you have to count from center to center. So this is a special skill like that. Only for average acceleration question, you then need to take note that the time you always base from the center to the center. Then you count how many dots there are. And some question very evil one, right? They can even not go to the center. Sometimes they can be right side 3 dots, left side 2 dots. So if left side 2 dots, the middle is actually a gap. Then can be like what 3.5 dots also can one. Yeah, so you just take note that for average acceleration, it's always middle to middle. That's the skill that you need to have. Yeah, so you have to learn from here. It's a unique skill for this question. Then lastly, as you can see, your answer will be 0.4 minus 1, as shown here, divided by 0.075. Then this is the answer. Done. That's all. Okay, I shall move on. For those online, are you done copying? Once you're done copying, can you click the thumbs up button to let me know? Any questions so far? You want to clarify? For Justin and Errol, once you are done, you let me know, okay? Then I'll move on. This one, no, it's not O level. This is IP. This is strictly only IP. Yeah. If you are in the O level stream, I'll recommend that you attend the O level class. Because for Sec 3 physics, we have IP and O level. Yeah. Okay, so I shall move on. Okay, so for the next part over here, it will be graph. Yep, so whenever it's graph, need to know how to convert. So for displacement time graph, gradient will tell you the velocity. Then velocity time graph, you look at the gradient, they will tell you the acceleration. Then from acceleration, how do you tell velocity? You look at area under graph. And velocity time graph, how do you tell the displacement? You count the area under graph. And by the way, my area under graph is not really totally under lah. I think this time you should know. If my graph is like that, okay, this is the area under graph. But if my graph is like that, right, it's not under. Under then you are infinitely no end. Yeah, so that's why if it's the graph is at the bottom, your area under graph should be more of between the graph and the x-axis. Okay, this one don't need copy lah. It's okay. We'll move on. Over here, need to know how to interpret the graphs. So here are some examples. How do you interpret the graph over here? This is a displacement time graph. So first, always check the y-axis. If this is displacement, then how do we tell the velocity? It would be gradient. Because as you can see over here, the displacement time graph, gradient tell you the velocity. The reason is because if you were to calculate the gradient, right? Gradient isn't it y2 minus y1 over x2 minus x1? And y-axis is displacement. X-axis is time. Displacement divided by time, isn't this velocity? That's why the gradient tell you the velocity. So it's not just because like, okay, teacher say must memorize. Okay, then you memorize gradient is velocity. The reason is because if you use the gradient calculation, you can really derive velocity. So it's actually true. Now, let's take a look at the first section here. How would we describe the velocity? The velocity is the gradient. And how is the gradient? The gradient at the start is this steepness. At the end, same steepness. If the steepness is constant, that means this is actually constant velocity. So don't mix up. This is not increasing. It is the displacement that is increasing. Because the displacement is from 0, now it becomes 50. So displacement increase, but the velocity is not increasing. The velocity is constant because the gradient is the same steepness. So don't get confused. Then next is that for velocity, because it's a vector quantity, need to indicate the direction. As long as it's upward sloping line, it will be positive gradient. Downward sloping line is negative gradient. That's why in this case, it would be positive velocity. Next part, for the second region over here, let me color code it for you. People, can you follow and copy this down? Yeah, so follow and copy it in. For the next section over here, we would say that what's the displacement traveled? If you keep on remain at the same spot at the 50-meter mark from the start line, if you're always at the same spot, means you are not moving. That's why displacement is 0. Next, what about the velocity? Velocity is the gradient. And it's horizontal line. So horizontal line means 0 speed. That's why we would say that this is at rest. For this topic, try to use the correct term, Ken. Don't use the word stop. Use the word at rest. So can you write down at the side to remind yourself? Correct term to use is at rest. Don't use the word stop. Yeah, so this is the keywords that you need to answer open-ended questions for this topic. Next part over here, it would be same thing. Let's interpret again. For the displacement, we can see that it is from 50, it becomes 20. So that means the displacement decreases. Next, for the velocity, which is the gradient. How is the gradient? So it will be from very steep, it becomes very gentle. So steep to gentle, that means gradient decrease. And the gradient is downward sloping line. Downward sloping line, isn't it negative gradient? That's why it's negative. That's why once your velocity is negative, you are actually reversing. So let me highlight for you. Velocity negative means you are reversing or you are moving in the opposite direction. Last section over here. Likewise, let's label everything in displacement. From 20, you go back to the start line. That means displacement decrease. So the come down is, the decrease is for displacement, not for the velocity. Because for your velocity, which is the gradient, the steepness at the start and the steepness at the end is the same. That's why velocity is constant instead. So take note, velocity is not decreasing. Velocity is constant because the gradient is constant. Gradient is the slantness of the line. So the slantness is the same. That's why velocity is constant. And I need to include the direction. This downward sloping line is negative. That's why it is still reversing because negative velocity means you're going in the opposite direction. Done. That's all. Yep. So make sure you follow and note down everything. Okay, so for those online, once you are done noting down everything here, you can move on. Can you click the thumbs up reaction button to let me know? Then I'll continue. Error, you done? Taking a bit long. Error, if you are still not done, maybe you take a screenshot. I'm moving on in 3 seconds. Okay, so ready, 3, 2, 1. Okay, I shall move on. Okay, so moving on to the next part, which is VT graph. So VT graph is actually one of the best graph that you should draw for MCQ and open-ended. So can you remind yourself that recommended to always draw in whenever you can't solve any MCQ and open-ended. The reason is because it is a very useful graph. It can have a lot of information. Like you see this VT graph, you can tell the V, right? So you see VT graph, you can tell what's the V and T, of course, right? Based on the axis. But you can also look at the gradient. Gradient of VT graph tells you the acceleration. You can also look at area under graph. Area under graph give you displacement. By the way, displacement is letter S. S is not speed. S is displacement, okay? S is displacement. So do you think that this is a very useful graph? One graph can give you 4 quantities. That means most likely you will be able to solve your open-ended and MCQ questions. Okay, then likewise also, why is the gradient the acceleration? Because gradient is always change in y over change in x. And in this case, the change in y is velocity. Change in x is time. So remember just now the formula, the change in time. So it's like v minus u. You know this acceleration formula ma? Yep, that's why gradient is the acceleration. Then area under graph likewise also. Area under graph, if okay, I use something simple like maybe triangle here. Triangle is half times base, which is times height. Height is velocity. The half you can ignore because half is just a number, which later the time we also sub in a number, right? Yeah, so mainly we just look at T and V. Speed times time, isn't this distance also called displacement? Yeah, so that's why all this is really you can calculate and deduce it. It's not just need to memorize. Yeah. Okay, so let's take a look at the first section over here. In this case, for the velocity, I think you can tell, right? Velocity from 0, it becomes 50. That means for the first section, the velocity increases. Next, what about the acceleration? The acceleration is the gradient of the VT graph as shown over here. The gradient is the acceleration. Yep, so that's why in this case, it would be at the start, this steepness. At the end, same steepness. If the steepness is the same, that's why this is actually constant acceleration. Okay, because the sluntness is the same. So it's V that increase. Acceleration is not increasing. Acceleration is constant instead. Next part, over here, let's take a look at the V. V is always at 50. That means we will say that since you keep driving at the same speed, that means they are driving at a constant speed. Oh yes, and velocity is the vector quantity. We should include the direction. So can you add in the plus sign for velocity? Yeah, add in the plus sign for velocity. In this case, for velocity is constant and positive, that means it's still moving forward. So I'll add it in. Constant acceleration is forward. The pink color section here is also still moving forward. Next, what's the acceleration? Acceleration is the gradient. Whenever it's horizontal, it's not constant. Horizontal is 0 instead. Because remember, I went through with you just now. Go up is positive gradient. Horizontal is 0 gradient, so this is 0 instead. So that means it's not accelerating. True, because you keep driving at a constant speed. You keep driving at the same speed. Next part, over here, the velocity is from 50, it is going to 20. That's why the velocity here is decreasing, but it's still moving in the forward direction. That means I'm moving forward still, but I'm getting slower and slower and slower. Next, for acceleration, which is the gradient. How is the gradient? From very steep, it becomes gentle. So that means the gradient decrease plus downward sloping line. Downward sloping line, isn't it negative? That's why I write in negative sign. And take note that whenever acceleration is negative, it can mean two things. So let's write it down at the side here. Negative acceleration. This is very important. This one you will keep on need to refer back to this point one. Yep. So this one need to know. Negative acceleration can mean two ways. It can mean that you are still accelerating. So that means you are still speeding up, but in the negative direction. That means I am reversing. But when I reverse faster and faster and faster and faster. Can you follow and copy it down? Yeah, note it down. That's why I'm accelerating in the negative direction. I'm speeding up in the opposite direction. Another way to look at it is you can base on negative acceleration is deceleration. What is deceleration? Deceleration means you are slowing down. But you are slowing down in the positive direction. Yeah, that's why the negative here refers to the speed slowing down. Yeah, but you cannot slowing down in negative direction. If you slow down in negative, become double negative. So slow down in negative is actually positive acceleration instead, because double negative get positive. But very rare schools will test on double negative. So far, only Hwa Chong will test on double negative. Yeah, most other schools won't test. Okay, now I continue on. So this part over here, how do I know this negative acceleration is which one? Is it the left or the right? So let's take a look at the speed. You are slowing down. Slowing down, isn't it the right side? That's why we would say that this is actually a actually don't need right, it's over here. That is actually a deceleration because you are slowing down. Yeah, got the word slowing down. Then moving on to the next part over here. For this section, what happened to the speed? The speed from 20, they come to a rest. So remember this topic, don't use stop, use the word rest. And the velocity from 20 becomes 0. It means the velocity decreases. But the velocity is still in the positive region. It is still above the x-axis. That's why it is still moving forward. Then you see, positive. Positive means forward. Just that it is becoming slower and slower as it keep moving forward. Next, for the acceleration, which is the gradient. In this case, this is actually the steepness at the start and at the end is the same. That's why the gradient is constant. And this is downward sloping line. Downward sloping line means negative gradient. So same thing again. In this case, the negative acceleration means deceleration. Yeah, because it is still slowing down. That got the word slow down. That's why you choose deceleration. And the last part over here, it would be this part here. This is something that is things to take note, important. Need to know over here, when it's in the negative region, is it becoming faster or slower? So can you see that the speed originally is 0, then towards the end is negative 20. So you need to know that it is increasing. So this is actually something special. It would be that you need to take note that math and physics, they look at it differently. For math, if you compare 0 and negative 20, 0 is bigger. So by right, if negative 20 is small, by right, if it's a smaller speed, wouldn't it mean that you slow down? By right, it should be a decrease from 0 to negative 20, right? But it's not decrease, it's increase instead. Because physics is opposite. For physics, negative 20 is bigger instead. The reason is because the negative over here refers to the direction. But when I look at the speed, at rest means you are not moving. Versus negative 20 means I'm reversing it. When you totally stop versus you are reversing, wouldn't the reversing one be at a faster speed? That's why for the negative 20, it should be faster. It should be a higher speed. That's why it's bigger, greater speed than 0. So take note that math and physics opposite. Because in physics, negative is for the direction. But when you look at the magnitude, 20 is bigger than 0. That's why negative 20 is at a higher speed than 0. That's why in this case, we would say that the speed is increasing. So I write down over here, speed increases. Then next would be the acceleration, which is the gradient. Yep, so in this case, how is the gradient? The steepness is the same, right? So same steepness means constant. No space. I think I need to write a bit more to the left. So the gradient is the acceleration. It is constant. Plus, this time round, because it's negative region, but then this is, so it's, okay, so it's in the negative region with a negative gradient. So that means negative, negative. Can you see? Negative region, because below the x-axis, plus downward sloping line, negative gradient. So double negative will become positive. So actually this one, we'll call it as acceleration. So let me just highlight it for you. This part here, the double negative here is actually acceleration. It's a positive acceleration. Cause can you see my speed, increase speed what? If I becoming faster, aren't I accelerating? So be careful, okay, this is a bit tricky. So this is acceleration instead. Okay, then the next part, horizontal line, it would be similar as on top. So I will just quickly copy it down. It's the same. So V is constant, but then it's negative. That means the object is reversing. And then the gradient, I just copy from on top lor. So it's just exactly the same. Okay, then for the last region over here. For the last segment here, this one is a little bit tricky also because it's in the negative region. Yeah, then there might be some double negative cases. Okay, so how to interpret this? Likewise, for the speed, how is the speed? Do you realize you're coming to a stop? So if you're coming to a stop, that means you are slowing down. And for your velocity, can you see they are negative value? That's why V, I will put in negative sign. So that means I'm reversing, but I'm reversing slower and slower and slower until I come to a rest. Then next for the acceleration, which is the gradient, how is it? In this case, the slantness is the same. That means it would be constant. But upward sloping is positive. And this is in the negative region. So positive times negative, it will become negative. So this one is actually no space, negative acceleration. Then now, whenever it's negative acceleration, you need to decide, right? Is it left or right side? So you check the speed. The speed is slowing down. So slowing down is right side. So actually this one is a deceleration, which is true. Because can you see, I'm slowing down, that means I'm decelerating. Yeah, so just be a little bit more careful for acceleration. There might be like this kind of like no times negative, then it becomes like negative instead. So you have to be really careful. Okay, yep, so done. That's all the annotations over here. For those online, are you all done copying? Okay, wait, let me answer Justin's question first. So Justin is asking, for this graph, the acceleration is still in the forward direction. Wait, depending on which region you are looking at though, because not every section is moving forward. It is only the top one that is moving forward because you see, when your velocity is positive, it means you're moving forward. If it's negative, means I'm reversing. So if you're talking about the bottom half of the graph, you are actually going in the opposite direction. Yeah, so that's why your statement on acceleration is still forward direction when, oh, sorry, I didn't see your behind part. Then yeah, you're correct. When in the positive y reach, correct. Then in the previous graph, oh, you mean the earlier on this one? This one is because the axis is different. So you are saying that the acceleration can be negative in positive y value. Yeah, because when you are slowing down means deceleration. Deceleration means negative acceleration. So yep, even though in the positive region, you might have negative acceleration. So did I manage to address what Justin trying to ask? Like, Justin, you okay? Anything else you want me to further clarify on? Or maybe like, did I not answer your point? All good? Okay. Then for Adviata, you're asking for the last part of the graph, okay, the dark green part, when V is negative, you are saying is the acceleration constant? Yes, sorry, because no space, I squeeze until very small there. A equals constant. So yes, acceleration is constant. Then you say that the acceleration is it a negative or positive value? In this case, because it's a positive times negative, it would be negative acceleration value. So the answer is negative value. So Adriata, is it okay? You need me to further clarify anything? All good, huh? Okay, so for those online, I take it that you should be done copying, right? Since I keep answering questions, should be done copying by now, right? If you're not done, you take a screenshot, huh? I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so next part over here, this one depends on school. Like for RI and RGS, you all don't use 10. So you follow what your school say, like the 9.8 or 9.81. Okay. So next part over here, this is the one that is the very common misconception. A lot of students tend to like answer wrongly. So this part, please study more thoroughly. Things to take note is that when you have air versus without air, your VT graph is very different. Without air, no matter how heavy or light your object is, the graph will still be the same. Why? Because usually, we always imagine if I drop a heavier object versus light, heavier object always like boom, reach the ground faster, right? But without air resistance, it's actually not true. The reason is because if you were to look at the speed or the velocity, speed is always distance divided by time, correct? That means if you look at the formula, there is no mass inside, what? If there is no mass, then your mass won't affect speed lah. But if you are thinking, like KE, kinetic energy, the energy in the kinetic store is that it's like half mv squared. But I'm not asking you on kinetic energy. True, kinetic energy is affected by both the mass and the speed. But I'm not asking you to solve for kinetic energy. So there is no need to think of the mass affecting the kinetic energy. I'm only asking you for speed. Speed, if you look at the very first page of the notes today, is distance divided by time. That's why there's no mass. So mass won't affect. So the most iconic video that usually school teacher tend to show you, it would be you use the world's largest vacuum chamber video to help you to remember. If your school teacher haven't shown it to you before, I'll just show you a short clip. A quick one. I will just voice over it. So what happened is that they will suck out all the air, then they will press the button to release that. So now it's no air already. So bowling ball versus feather. Oh, this is played in slow-mo actually. You realize that the bowling ball and the feather, they are actually falling at the same speed. So this entire region is actually a vacuum chamber. Yep, so this actually shows that without air resistance, you see, different mass will still fall at the same speed because speed is distance divided by time. There is no mass inside. Yeah, like that. Yep, so you based on this video, you try to remember that, yep, without air resistance, heavy and light object, the graph is the same. And in this case, you need to know that the G would be equals to, the acceleration would be equals to the gravitational acceleration. And it will be equals to, can you write according to your school? If your school say 10, you write 10. If your school say 9.81, you write 9.81. So this applies to even the object you throw up and come down. So even though my object you throw up and come down, we always see that like when you throw an object, you throw up and it fall down, how would we draw the VT graph? Any idea how to draw the VT graph? Xingye, do you know? Like that. Wow. No leh. Because when you push from your hand, isn't the speed very fast? If the speed is very fast, it shouldn't be zero. No, it'll be like that. Why? Because when you push from your hand, the speed is very fast, right? Then when you reach the highest point, it will momentarily pause. Then when it comes down, it will be because of gravity pull, it will move down faster and faster and faster. That's why you see from pause, it will move faster and faster and faster. Because remember, in physics, -20 is bigger than 0. Yep, so for such an object, even though you have different direction, go up, come down, right? You see different direction, right? Go up and come down. It is still, if I were to ask you, what is the acceleration? The acceleration is still 10, because a lot of students tend to get tricked. So this is the misconception part. A lot of students think that, here my speed is 0. So they thought, oh, my acceleration like changed. I slow down. So they thought acceleration decreased. This is incorrect. Acceleration is not decreasing. Acceleration is always equals to g. Because as long as you are on free fall, you are experiencing the gravitational acceleration. And even if you look at this line here, remember, gradient of a VT graph give you the acceleration. Can you see that this is a straight line? Straight line means that the gradient is constant, right? Yeah, so it's constant at your G value. So take note, even though your speed change, your acceleration is constant. So I write now over here clearly, so you take note, okay, this is the common misconception part. Yeah, V will change, like increase, decrease, but A is constant instead. This is the puzzling part, because a lot of students think that, my velocity change means my acceleration change, but actually it's not the case. Okay, then moving on to the right side over here. So in this case, when there is air resistance, heavy and light object will have different graph. This one quite common sense, right? Because now we have air. You drop the bowling ball, sure the bowling ball drop down first, ma. The feather will float up in the air. So that's why heavier object, you see, the speed is a bigger value. Can you see the value here is bigger than the speed over here? Yep, so need to know that object that is heavy will fall down faster. Yeah, why? Because when you have air resistance, to reach terminal velocity, it must be such that the weight and the air resistance must be equal. That's why weight matters, lor, right? Because to reach terminal velocity, I need to take into account the weight. That's why weight matters. And for this case over here, if there is air, take note that your A is no longer equal to G. Why? Because once you reach terminal velocity, so this section here, when it's horizontal line, it's terminal velocity. At terminal velocity, can you see my speed is constant? If my speed is constant, that means my acceleration would be zero, right? Because if I'm traveling at constant speed, I'm not accelerating, ma. So you see, this is the confusing part, is that when it is without air, your acceleration is constant. But with air, your acceleration is zero instead at terminal velocity, okay? Only for the last section here. Yeah, so these are the common misconception among students, so just be really careful. Okay, then next part on terminal velocity, I think this one you all already know, so I think I don't want to go through further. Yeah, so I shall, oh sorry, before I move on, just to check for those online, are you all done copying? So once you're done copying, can you click a thumbs up? If you still got a lot to copy, maybe you'll take a screenshot. After you screenshot already, then you click the thumbs up button, then I'll move on. Then you can slowly copy it on your own at home. So once Justin and Angela done, then I'll move on. Angela, you done? Oh, done. Okay, can. Okay, so moving on. So this part here, I think all this y'all should know from school. So all this I don't want to repeat anymore because nothing special. Yeah, just as per normal. So just take note that originally you have one terminal velocity. You open parachute will have another terminal velocity again. For this equation here depends on your school, cause like for RGS, you are not tested on equations of motions. But then for like NY, yeah, you are tested. So yep, if your school do test it, they need to know what they all means lah. So this one I think you all should know. So I shall move on. Okay, so for this section here, the MCQ, can I get you all to you try all the MCQ bah? Yep, then I will go through it. Because the answer key that I'll be sharing at the end of the lesson, the answer key don't have explanation for the MCQ. Yep, so can you finish up the 5 MCQ now? Then I will go through the answer with you. Yep, do now. For those online, once you are done with the MCQ, right, all 5 questions, can you click the raise hand button to let me know? If you can't click the raise hand button, you can just type it in the group, in the Zoom chat, the word done. Then I'll know that at least you are done. Then once you're finished, I will go through the answer. Let me get a bottle of water for you. And the rest of you who are fast, meanwhile waiting, once you're done with the MCQ, why not give it a try to do the open-ended? Angela, Isabel, Justin, are you all done? If done, remember to click the raise hand button to let me know. And the rest of you, meanwhile waiting, can you do the open-ended section? Okay, so I think I shall go through. Angela should be almost done soon, right? I review the answer first. Sorry, because of time constraint. Okay, so yep, this is the answer. Can you let me know which question number that you all would like me to go through? You want, you can type it in the Zoom chat. Yeah, then I'll go through those questions that you all need me to. So how, which questions to go through? Do you have any question that you want me to go through? Oh, correct. Oh, very good. So how, any questions to go through? If everything correct, that's good. So really, if you all don't tell me any question number, I will take it that you all really don't need me go through. I will move on to the open-ended. So all good. Okay, so okay, yep, I will go through question number 1 and 5. Okay, so for question number 1, by the way, for Emma who just logged in, do you have the lesson material? Do you need me to like provide you the lesson material? Yes. Okay, then never mind. Okay, I will move on. Okay, so for question number 1 over here, so they said that what is the acceleration at 2 seconds? This is the speed time graph. For speed time graph, how to calculate acceleration? So can Adviata let me know? How do you calculate acceleration in a speed time graph? Just now you went through, right? Is it gradient or is it area under graph? Yes, correct, the gradient. So for at the 2 second timing, how is the gradient? The gradient is like this slantness, right? So this slantness, maybe you can use this point and this point because the slantness is consistent for this blue color highlighted part. So that's why you find the gradient for this section, which is y2 minus y1 minus or over x2 minus x1. That's why this would be 10. Adviata, you done copying the correction? Can I move on? Okay, so moving on to question number 3 over here. there is this acceleration time graph, and they're asking you what is the corresponding velocity time graph. Okay, so what you need to do is that, remember, velocity time graph, gradient tells you the acceleration. Okay, so let's check for the first part, the gradient, which is the acceleration. How is the acceleration for the first part? The acceleration is constant and positive, all right? So that's why now I just copy down. Acceleration, it should be constant and positive. So now let's check. Is the gradient constant and positive for the first section here? So, yep, it is constant because the steepness is the same, right? So, yep, constant and positive. Okay, so for the first section, it is correct. Moving on to the second section, which is this. This one, how do we label the acceleration? This is actually constant, and this is negative region, constant negative. So now let's take a look at the gradient of the next section. Is the gradient constant and negative? In this case, it is constant. Sorry, it's not constant, sorry. Horizontal line is 0, right? Because remember, for graph, the horizontal line is 0. So, yep, this is not correct. That's why the last section here, not correct. So, A cannot. Oh, yeah, by the way, Isabel, which option do you choose? I explain the correct option first, D. So for D, it would be the gradient, which is the acceleration for this part here. How is it? So let's check. This is constant positive. This one here, also constant, right? And also upward sloping line. So upward is positive. So yep, it matches with the top. Constant and positive. Then for the second part over here, the gradient, how is it? It is constant, right? Because at the start and at the end is the same slantness, same steepness. That's why it's constant. But downward sloping is negative. Then it matches. So yep, correct. Also D is correct. So for okay, can. So Isabel, you want me to explain your option then, or don't need? So don't need, okay, can. Then I'll move on. Okay, so question 5, okay, right? Okay, then don't need go through anymore. Lor. Okay, so let's move on to the open-ended. For question number 6, do you manage to solve it already? Because like, while I'm going through and all, don't know whether you manage to solve it. So for those who solved it, what's your answer for part A? Do you manage to solve? 1.2. Yes, 1.224 seconds. So if you want to follow the SF in this question, it would be 2 SF lor. So you round off to 1.2 seconds, 2 SF. Yep. So if you haven't done it, maybe you want to just like write down the answer, then you can go home and give it a try to see whether you can solve it. This question is easy lah, so this one no problem. Okay, then moving on to part B. So you managed to solve it, right? What do you get? 290,000 kilometers. No leh. Oh yeah, sorry, there's a tiny typo error. Can you change it to deceleration instead? Okay, so for those of you who managed to solve it, let me just briefly go through. I will review the answer soon. Mainly, you need to know that to calculate deceleration, obviously you need to use the A equals to V minus U over T. So when you sub in, right, the V and U, you go and check what's the number in the graph. The time, you can actually use the answer from part A, correct? Yeah, because part A is calculating the time. So for the part A value, you sub it into the denominator. By the way, once you press calculator, the number you get, it should be negative. That's why in your answer, right, because if acceleration is negative, but the question is not asking acceleration. The question is asking for deceleration instead. That's why in your answer, you cannot have negative sign. Cannot have negative sign. If you write negative sign, your answer is wrong. Because deceleration already has the negative connotation. So if you put a negative answer, it becomes negative, it becomes acceleration instead, So be careful, okay, that whenever they ask for deceleration, even though your number from negative, when you write your final answer, cannot have negative. Clear? And by the way, if you manage to solve it, the answer would be negative 23 in 2SF. Come, guys, I take a look at your working, see which part went wrong. Which? So you took, why not you look at the period where part A is happening? Yep, so for part A, for the car to come to a complete stop is from the 100 kilometer per hour, right? Yep, which is 27.77777. So that's why that would be the initial speed. Then eventually it comes to a stop. That's why your final speed isn't it 0? Then T is part A minus sub in part A value. You can. So how everyone, do you all manage to solve and get the answer for part B? Once you are done with part B, if you can move on to the next question, can you click the thumbs up button to let me know? For Isabel, Angela, Edviata, and Error, are you all done? Can I move on? Done, ah? Okay, okay, then I move on then. Okay, so moving on to the next question here. Question number 7. I would say this question is overall manageable. I'll let you to do on your own as homework, okay? Yeah, this one I think, yeah, can do. I think maybe we take a look at the graph conversion because I think generally graph conversion, yours seems to be, students tend to be weaker. Can you do part D now? Yep, you do the graph conversion now? Yep, do part D now. Mini is the shape. Can you get the shape correct or not? Yep, you give it a try. Once you are done for part D, can you click the raise hand button to let me know? Raise hand because the thumbs up always disappear very fast, then I cannot keep track. Yep, so once you are done for just this graph drawing, just the shape will do lah. Yep, so once you are done with the shape, then you raise hand. The values for the x-axis and y-axis don't need yet. The x-axis and y-axis value, you need the calculation from the previous parts, which we haven't do yet. Yeah, so just the main shape will do long. Whether you know how to convert will do. So read the question carefully. They only want from section A to B, not the entire thing. Only A to B. Once you are done, click the raise hand button. Then meanwhile waiting. After you are done, why not move on to do the in front part? Yeah, you can do the question 7 ABC. Yeah, since I said that it will be your homework. All right, good. Hey people, why you're taking so long? Just A to B only, just one section, just going up. Are you done with the shape of the graph? Just the shape will do. I don't need the x and y axis value. Are you done with the shape for just one section, A to B, upwards? Once you are done, can you click the raise hand button or at least can you type it in the chat to let me know that you are done? Then I can move on and review the answer to you. Okay, due to time constraint, Error and Angela, sorry, I can't wait for you. I will just review the answer. So the answer would be like that. Okay? Anyone got this wrong? Anyone want me to explain? If not, I'll just move on. By the way, after you finish the in front part, can you add in the values? Okay, okay, then I'll go through for Adviata. Okay, so for this part over here, this is S, which is displacement. So read carefully, displacement. I told you just now also that S is displacement. Based on over here, what happened to the velocity? Let's write it down. Velocity is Can you see from 5, it becomes 0? It means the velocity is decreasing. And this is positive 5. That means positive. Decreasing and positive. So for this graph over here, remember, the gradient of a displacement time graph tells you the velocity. Then I copy this in. Yep, so I write down, arrow down and plus. That means now I need to make sure that my gradient is positive. Remember, positive gradient is upward sloping line. That's why you must draw the graph go up. And then the go up already, right? Then it must be with decreasing gradient. That's why you draw a graph go up. But for graphs that go up, which one has decreasing gradient? It would be the highest graph. Yeah, the highest graph has decreasing gradient. Yeah, so that's why this would be the answer. Then based on your answer in part A and B, you are supposed to find out what the x-axis and y-axis values are. Yep, then done. So Abiata can understand? Okay, then I shall move on. Will be good to copy this down at Abiata, like the explanation. Yeah, so you label in the previous page graph the question, as well as you label on part D. Yeah, so that you know how to derive the answer. Okay, so moving on to the next question. Question number 8. A is definition. This one easy. I let you do on your own. This one is a very simple graph, so I don't think I need to go through. Yeah, generally, they are all pretty manageable. I think you can try on your own. Yeah, I think no problem. Yeah. So you all give it a try. I'll be providing you the answer key later. Then after you do it, you can check. The answer key will have the working. Yeah. Okay, so I shall move on to the next chapter, dynamics. Okay, so for dynamics, this part here, I don't want to go through anymore. For this one, you all should know the difference between mass and weights. I go through the thing that is newer for upper sec, which is Newton's 3 laws. So you need to know that Newton first, okay, by the way, all these law here, right, if you have WA, don't need to memorize the law. They won't ask you state the law. They only ask you state definition, but they won't ask you to state the law. So don't need to memorize the law. Just need to know what is it about will do. So what is Newton's first law? In summary, let me write down in red. The summary will be Newton's first law is related to inertia. And Newton's first law is also when there is no resultant force. Then they mention unless a resultant force acts on it. It means there is no resultant force. It's Fr, okay? Fr means resultant force 0. Newton's second law, in summary, it is just the formula, which is the formula F equals ma. And since you can do calculation, means got resultant force. And force, since it's a vector quantity, it can be positive or negative. Newton's third law, in summary, is just the action-reaction force. Action-reaction force. Yeah, so this is to summarize it. Then things to note in greater detail would be, you need to know that inertia depends on only mass, not weight. So one of the common mistakes among students, it would be that they say that it depends on weight. No, no, no. Depends on mass. There's a difference, right? Because mass and weight, there's a difference of g. So actually, they are similar, but not exactly the same. So what exactly is Newton's first law? Newton's first law is just saying that they want to remain the same. Same for inertia also. Both is just saying that they want to remain the same because everyone is always very comfortable with our current status. We want to remain the same. So that means an object, if it's moving, it will want to continue move at constant speed in a straight line. If it's at rest, it will want to remain at rest. That means just remain the same. So for inertia, it's also likewise. It will just want to remain the same. That's why, like, if we were to maybe sit in a car, then if the car turn right, you realize that your body, you will actually lean towards the left because the object will want to always remain the same. If you are moving straight, they will want to continue to move straight. Yeah, so want to remain the same. But the vehicle force your body to the right. That's why you will lean left, trying to continue to be the same. Yeah, then likewise for like car braking also. When a car brake, is that physical object stop. But my body want to continue forward. That's why when cars brake, we tend to lean forward. Okay, right now? When car brake, we will lean forward. Then when car accelerate, if you accelerate too fast, for someone who is not like leaning on the backrest, when you suddenly accelerate, the person will actually fall backwards. Yep. Or maybe like if you're in a bus, if you never hold the handle, if the bus move forward very fast, you will realize you are like toppling towards the back of the bus. Yeah, so you will lean backward. So it's always opposite lah. You want to go forward, your body lean backwards because they want to remain same as just now. Then if you brake, you force yourself to stop, they want to continue move forward. Okay, then Newton's second law is just purely calculation, which how you present your answers. So if you were to always use this standard template, right, then most likely, no matter how difficult the question is, you should be able to get the correct answer. So this is usually how I teach my class, which is you always define the direction first, and the direction that is the positive direction would be the first direction you move. Like if you have a ball you throw up and then drop down, right? Is it up or is it down that is positive? Since the ball first moved up would be positive. Then you write this in. So below, you always write in the formula. Then on the right side is always the free body diagram. So if you can't tell what the forces are, best is you own self draw out a free body diagram, like with a rectangle, then you label all the forces in. So this is my so-called standard L-shaped format. Once you follow this L-shaped format, then your calculation usually will be correct lah. Yep. Okay, so later I'll show it to you by trying out the practice questions later. We'll keep using this L shape. So remember, when I say L shape, I'm referring to this part over here. Okay, so I shall move on. Just to check for those online, are you all done noting everything down? Can I move on? If done, can you click the thumbs up button to let me know? Angela and Justin, once you're done, you'll let me know. So Justin is asking, what does taking something as positive means? Oh, so this blank is for you to fill in the direction. So if I'm talking about the object throw up, come down, my blank would be taking upwards as positive. If I'm talking about a car, a car moving forward, then got brake, and then got friction, and then maybe I'll say if my car is moving forward, then I'll say taking like forward or rightwards as positive. So the blank over here is for you to fill in the direction. It can be upward, downward, leftward, rightward, according to your question. Okay? Okay, no problem. Okay, so I shall move on. I think that are you done copying, Justin? Okay, so moving on. So for Newton's third law, need to know that you must fulfill all four criteria. So if you miss out one of it, then cannot. So if you fulfill 3 out of 4, it's not action reaction force. So first, you must make sure that the magnitude, that means the number of Newton, it must be equal. Act on different bodies. By the way, bodies means object. So what they are trying to say that you must act on 2 objects and must be opposite in direction and same type of force. The recommendation for the same type of force would be, the favorite ones are normal contact force. Because example, like if I have maybe, this is my writing pad that I write on the screen now, and I have maybe my correction tape. Since my 2 objects are touching each other, there will be two-way normal contact force, because the normal contact force can be exerted by this correction tape downwards. So by correction tape on the black surface. Or it can be, because my correction tape can stay in this level, is because my surface is holding it up. So it can be also the normal contact force by black on correction tape. So it's by black on white, by white on black. Okay, so that's why same type of force. So usually we like normal contact force is because it can be two-way to fulfill the criteria of opposite in direction and different object, right? Just like one black object and one white object. Another common answer that you should choose would be gravitational force. Don't choose weight, because weight is usually just like that, one way. But if it's gravitational force, you will learn it soon in JC physics, is that gravitational force is actually the attraction between the two masses. So if you were to have 2 objects that have mass, there will be gravitational force. So it's like even me, I have mass, right? That means I can also exert gravitational force. So instead of labeling weight, recommendation would be you label as gravitational force. And then to be reaction force, since the Earth attract the box will also attract the Earth. So you just draw an arrow of similar length to show the Earth being attracted in the opposite direction. So this is also gravitational force. So this will be reaction force because you fulfill the criteria of same type of force. Your arrows are in opposite direction. So yep, you fulfill the third criteria, opposite in direction. Next, there are two objects, right? The Earth and the box. So, yep, you fulfilled the act on different bodies. And then, and the opposite bodies, maybe let me be clearer. This is by box on Earth. Then the other one is by Earth on box. So you see, it's really opposite, by box on Earth, by Earth on box. So this is how you actually phrase for Newton's third law type of question. You always use such words, by something on something. Yep, then lastly, you just draw the arrow to be same length, then yep, equal in magnitude also, you see, you fulfill all four criteria. Okay, then I shall move on to the next part, which is the scaled vector drawing. For those online, are you all done copying everything shown here? Once you are done copying, can you click the thumbs up reaction button to let me know so that I can move on? Angela, you done? Angela, you done? I think I will move on already. If not done, you take a photo. I'm moving on in 3 seconds. 3, 2, 1. Okay, moving on. Okay, so for the next part over here, it would be the scaled vector diagram. So for scaled vector diagram, how do you go about doing it? So maybe, for example, I say that I have an object. Okay, maybe I draw it over here. So I have an object. My object this time around experienced two forces. I experience a force that is like that, and I experience a force that is like that. So if I have like not parallel forces, like not up, down, left, right, then we cannot directly minus and plus. That's why we need to draw it out. So what you need to do is you can either use the triangle method or the parallelogram method. Personally, I would prefer triangle method. The reason is because if you look at the number of lines, you draw less lines. Parallelogram law, you draw more lines. The more lines you draw, the more time consuming it is, the more inaccuracy there will be. That's why triangle will be more accurate and can save time. Okay, so what's triangle law? I would say it would be I will call it as the rearrange the lines such that the monster know how to walk. So you imagine if I were to have, maybe I play some game, okay, then I have this like cute monster over here. So for this monster, they wouldn't know where to walk. It's like, should I walk up or should I walk right? You see, there's two paths, right? So the monster will be like, oh no, I don't know where to walk. So what do? You rearrange the lines such that the monster has a clear path to walk. So this time around, maybe I can shift the lines. So I can maybe shift the lines around such that like my lines can form a complete path. So maybe I draw this line first. Then later I then draw this line. Yep, so in this case, can you see that my monster will know how to walk already, right? He walked from at the bottom left, he walked right, then he walked up. So that means the monster start from bottom and on top. So this would be the resultant force. So that's why for this triangle method, it's just mainly you just need to rearrange the lines such that the monster know how to walk. So triangle law is not so simple like some of my students I see. Okay, my student didn't because I emphasized it. Yeah, but like generally I do see students that like they just triangle law, okay, very convenient. I draw these two lines, then I just draw a line, close it. Then triangle now. Then can you see the triangle? No, it doesn't work that way. Triangle law is not just I force it to be triangle. You have to rearrange the lines. This is the key point. Rearrange the lines such that the monster know how to walk without headache. That means if I were to rearrange wrongly, I write like that, then like that, also cannot. You see, where the monster start? Should the monster start from left side or should the monster start at the bottom? So this way also not correct. That's why I need to rearrange such that the monster has a clear path to walk without headache. Yep, so this is the triangle law. So in this case, so they actually draw like maybe this line, then this line they bring up lah. So then they bring up, then start to end. So once you connect start to end, this would be the resultant. And for resultant, you always draw double arrowhead in the middle. For the question, up to you. You want to draw at the end also can. You want to draw in the middle also can. Up to you lah. End or middle, either one also okay. But resultant confirm must draw in the center. Resultant cannot draw at the end. For parallelogram law, there's no need to rearrange the line. You just duplicate the lines. So can you see originally if this is my question and this is my question, if I have these two lines originally from my question, I just go and duplicate it. So then this line, I go and duplicate it over here. Then another line, which is this, I just go and duplicate it over here. Then can now. Then once you duplicate, make sure that they must be dotted lines. So actually this one a bit not accurate. It should be dotted lines. Because all this is you duplicate one. Only questions arrow you then draw in solid lines. So things to take note would be these two lines, draw in dotted line. You want to like maybe arrow out and like let yourself know, draw in dotted lines. Yeah, because this one is you duplicate out one. So that's the main rule of parallelogram law. So parallelogram law is about duplicating the lines. Triangle is rearrange the lines. That's all for this part. For those online, once you are done, can you click the thumbs up reaction button to let me know? Once you are done, thumbs up. Is Angela even still around? It seems like Angela like went missing. Okay, I shall move on. Okay, so moving on to the next part here on friction. This part, I think friction, you all should know it already by now. Just wanted to emphasize that, take note that there are two exceptions. The two exceptions where friction and the way you walk is the same direction would be walking. So you see, if you walk forward, friction would be forward. And friction is a contact force. So make sure you draw from the point of contact. Can you all follow me and label the word friction? So you shouldn't be drawing like the demo here because friction cannot be from the middle of nowhere. Friction must be from the point of contact because friction is a contact force. Hello people, do you all write this in? Can you follow and copy it in? So you see, if you are moving forward, friction will be forward. Why? Because in order for you to move forward, you need to press backward. That's why friction opposes motion. If you press backward, friction will go forward. Next, for vehicle moving also likewise. When vehicle move forward, your friction also forward. Why? Because in order for your vehicle to move forward, your wheel must rotate backward. So if your wheel rotate to the back or left, friction will point opposite lah, forward also called right. Yeah, because they need to oppose motion. Okay, so I shall move on. Should be done copying, right? Nothing much to copy. Okay, so then, over here, this is the MCQ section. Likewise, can you do the MCQ section now? Because for the MCQ, there is no like written explanation. There's only A, B, C, D in the answer key. So you do now. If you're wrong, I can explain it to you. Yep, so you do now. Then once you are done with the MCQ, you click the raise hand button to let me know. Yep, do now, do now. Isabel, can you change to the raise hand button instead? Because the thumbs up later will disappear. Yeah, then for those of you who are fast, meanwhile waiting, can you just continue to do the in front question? You know the kinematics question, some question you all skip, right? Because just now I said that it's like very manageable, like one mark time. Yeah, so you can go back to do the in front questions. The open-ended, I'll be going through some. So you don't do dynamics open-ended. So while waiting for the rest to be done, you do the kinematics open-ended. Can I just confirm, is Angela and Kimberly even around? Okay, then once physical student is done, then I will review the answer. We done with all five? Okay, great. Come, let's go through the answer now. Oh, sorry, I think my button a bit wonky. I cannot lower all of your hands. So maybe can you manually lower your hands, please? Thank you. So the answer would be, wait, sorry. Yep, so this is the answer. Can you let me know which question number that you would like me to go through? 2 and 3. Question 2 and 3. Okay, any more? Okay, I'll go through question 1, 2, 3. That's all right. Okay, so I start off with question number 1 first. Which of the following statement is not true? Since they have the same size but different mass, will they accelerate at constant rate? The answer is no, they won't accelerate at constant rate. Because if they never mention like vacuum, we will assume that usually got air. Because normally any experiment you do is usually got air. Is you must purposely suck away the air, then it's vacuum. So we'll take it as got air. And then whenever got air, how do we draw our VT graph? Our VT graph is like that, right? Then remember I told you, at the start, you got the acceleration. Then towards, so that means at the start is like you got acceleration, which is like equal to G. Then towards the end, what happened? Your acceleration became 0. So become got acceleration, become no acceleration. Your acceleration will change. So your acceleration is not constant. It's actually changing. So it's actually acceleration is changing, not constant. That's why option A is incorrect. Isabel, which option do you choose for question 1? And why do you feel that it's like not correct? Do you want me to explain to you? You choose B. You feel that S is lighter than R. Why? Like, why do you feel that S is lighter than R? You see, because R reached the ground first. Then correct what? Heavier object will reach the ground first, correct? Right? You imagine your bowling ball and feather, you drop. By right, bowling ball should reach the ground first. So this is true. So this is heavier. So option B is correct. Yeah, R is heavier. So B is true. But they ask me for not true. So must see the word not. Okay, next question would be question number 2. So I have to read the question carefully. Okay, so for question number 2 over here, is that they are asking you for the tension for baggage between 1 and 2. This one over here. So you need to know that for this part over here, how many boxes are they dragging? So this string is dragging how many kg? It's dragging 12, as in 1,200, correct? Because each of them is 400. So that means you're dragging 400 plus 400 plus 400. You are dragging 1,200. And tension is a type of force. So what's the force? Which is the tension? Force is MA, right? So times acceleration, which is 2. Then the answer is 2,400. The answer is just C. So that means if you look at the tension for the last part, this one, the tension will be the least. Because the last string here only pull one object. So it's very chill. As compared to the in front ones who are more likely to break because of more burden behind to pull it to the left. Okay, so the tension for each string are all different. Okay, then next question number 3. Remember for action reaction force, you need to fulfill the criteria, right? So one is it must be the same type of force. Okay, this time around, they never say what is the name of the force. So, okay, we can't do it. Next one, it would be equal in magnitude, which we also cannot tell because here they never say what's the magnitude. Next, it would be opposite in direction. So direction means you need to choose upward, downward kind. In this case, the answer they say is D, P, and S, which is true because upward and downward. Lastly, it would be opposite bodies or different bodies. That means it must be two different objects. So in this case, it would be parachute on man, man on parachute. Remember, this is also in a way opposite also, by who on who. So this is actually by parachute on man. This is by man on parachute. So yeah, you also account for the opposite interaction. So for Sing English option, do you choose? You should see Q and R. Okay, true, that is opposite direction. And then this time around, oh, your object is different. You got three objects now. Do you realize? You have man, earth, and parachute. By right, it should be only two objects. Cannot be three objects. You want to write down? Because yours is three objects. So three objects, wrong. It should be only two objects. Any other question to go through? If not, I move on to the open-ended. Okay, good that you got it right. Okay, let's move on to the open-ended question number 6. Over here, let's do a rough sketch on how to draw. Then you can use your own time at home to draw out the scale vector diagram. Let's read the question together. Figure 6.1 shows a leisure pursuit of called paragliding, and a person is attached to a parachute over here, and then they drag it along the sea by this rope tied to a motorboat. Figure 6.2 shows the direction of the forces acting on the person. So the person has a 0.7 kilonewton. So be careful. Whenever physics, the unit is wrong, best to quickly change it to the correct unit first. Because later, if you use 0.7, then your answer will be incorrect. So let me change it first. So kilo means times 1000. So this is 700 Newton. Can you follow me and copy it down? Yeah, write it in. Next, it is pulled by a constant speed of 7.5, and then there is a 1200, that means 1200 force. This is tension, so I'll label T. And then there is a drag force over here. So part A. Part A asks, why does the resultant force on the person is 0? So how, anyone have any idea what the answer can be? What keywords do you think need for this question? Correct. Constant speed means acceleration 0. Good. Thanks, Justin and Simi. Then? Yep. So if A is 0, then FR is 0. So this one need one more keyword. Need to identify what law is it. So which law is this? Second law. Yep. So you also need to mention that, oh, this is second law. Then carry on. So this will be the answer for part A. So I leave it to you to write it as proper sentence on your own at home. Can? Yeah, so just write everything in from constant speed all the way until second law. Done. So this will be the answer. Okay, so can I move on? Are you all done noting down the hints? Once you are done, can you click the thumbs up button to let me know? Then I'll move on. Isabel done copying the hints. Can I continue? Okay. So moving on to part B is the scale vector diagram. And you need to find the drag force. So remember I told you the best method is to use triangle law. Because if you use parallelogram law, right, it won't work if you have three forces. Okay, so let's add it in also. Just now I missed out mentioning. In this law over here, can you write down? For triangle law, it can be for two or more forces. But for parallelogram law, it's only strictly two forces. So that means parallelogram law is not like every time you can use. Because only two forces, then yep, you can do parallelogram. If it's 3, 4, or 5 forces, you have to use triangle. So actually triangle is still the better method. Have you all written this into the notes? Yeah, copy this into the notes. Okay, then now we come back to this drawing question, the vector diagram. So you imagine if you have you play game the monster is over here. The monster will be like, oh no, headache, I don't know where to go, right? Should I go up or should I go down or should I go left? So what you need to do is you have to rearrange the lines. So can you do a rough sketch, maybe at the side over here, on how can you rearrange the lines such that the monster has like a clear path to walk? So key point to take note is that because we mentioned that resultant force is 0, that means in your drawing over here, right, you should not have a resultant line because there is no resultant force. That means in the end, your arrows will just keep pointing, will just keep connecting until you can't have a start and end. Then your object will just, the arrow just keep going in circles. Okay, so for those online, once you are done with your doodling of how you can rearrange the lines, can you click the thumbs up button to let me know? Then I will go through the answer. Are you all done with the sketch? You all know what to do now, right? So I'm asking you, if you were to draw a scaled vector diagram, because I don't have time to let you measure with protractor accurately, you just do a rough sketch at the side. Yeah, you rearrange it such that the monster has a clear single path to walk, such that in the end the arrows just keep linking up, that you do not have a resultant line. That means there shouldn't be any start point or end point. Because once you have a start point and end point, then you can draw resultant line. But for this question, you cannot draw resultant line. I give a bit of hint. So usually among all the lines, the easiest to draw is, I'll recommend always draw the weight. Because the weight you know confirm is downwards. And based on the Newton over here, you know exactly how long to draw the line, right? So you start from vertical. Then can you connect the next line? How do you continue with the next line? Okay, I shall review the answer. So one possible answer would be this. I continue with this line here. This is the drag force. Then, wait, I think the drag force should be longer. Yeah, like that. Then after that, I can continue on with this line here, the 1,200. Yeah, so this is one possible answer. Or instead of connecting to D, I don't connect to D first. I can connect to 1,200. So I connect to the 1,200 first. Then I add D in. Yep, so your answer would be either the orange blue or the green blue. Yep, so your answer will be either orange blue or green blue. So this would be the answer. Okay, then next things to take note is that whenever it's a scaled vector diagram, there is actually a checklist. Yeah, so you need to make sure that everything is in. So what are the checklists? Number one, you must have a scale. And take note that scale is usually 1 cm is to something Newton. And make sure that this number here, it must be in multiples of 1, 2, and 5 only. So cannot be like 1 cm to 3 Newton. 3 cannot. So it can be 1 is to 4, 1 is to 2, 1 is to 10, also can. So this is the first checklist. Can you follow and copy it down? Yeah, copy it in. So this is what me as a teacher, whenever I look at my students' worksheet, when I mark, I will check whether got all these things or not. So these are actually your mark allocations also. Next, it would be, because the vector diagram, vector means it will have both magnitude and direction. So take note that for your magnitude, teacher will be only looking at the magnitude of the force, like how many Newton. So don't go and write the cm. So the cm is just for yourself to know, okay, how much I need to measure. But when you write, you see, you label everything in terms of Newton. Like over here, I'll measure, like maybe if I measure like 7 cm, but I still label as 700 Newton. Don't label as 7 cm. Okay, so label in terms of Newton. Next, magnitude and direction, right? For vector quantity, direction will be the arrowheads. So you must make sure that your arrows are correct. So take note that if it is like this situation where there is no resultant force, there will be no resultant line. And this happens usually when when the question say that, okay, they are at like constant speed, or maybe they are at rest. Because when constant speed and at rest, they are all not accelerating. Then you know, if A is equals to 0, means F is equals to 0. So when F is equals to 0, then you don't have resultant force. That means you cannot draw the resultant line. So usually for this scenario, when resultant force is 0, your arrow should keep going in circles. So can you see, there is no start and end. It just keep on go left, down, up, left, down, up, left, down, up. There is no start, there's no end. It will just keep going in circles. Just connect them in circles. Okay? Yeah, so can you write this in? So when there is no resultant force, you just keep linking them. So Justin is saying that once you use the scale and the exact angle, by right, this triangle, yes, it should be a closed triangle. It should not have a gap. If got gap, means got resultant force. So if example got gap, right, maybe on the line stop here and the line stop here, the gap, that means you can draw resultant already. So you start from here, right? You end on top. So start to end, and this become the resultant. Yeah, so by right should not have gap, because for this case is no resultant line. Okay, so people take note. This one is one of the thing that you need to take note, that no resultant line, just keep linking them in a circle. So-called or closed triangle. Yep. Okay, then the last checklist to take note would be, if the question got angles, make sure the angles from your question is labeled. That means in my diagram, I need to have the 45 degree and 40 Newton. So that means my drawing here a bit incomplete. I need to include the 45 degrees. So I will like draw a horizontal line, label here. Actually don't need horizontal line. Because if horizontally is 45, means vertically is also 45. This line over here is from vertical, so this one I need to draw a vertical dotted line. Then I label this as 40 degree. So angles from the question, you need to label it. If the question is asking you to write out what is the angle, that means like they want you to give an answer on what the angle is, then if your answer is maybe 30 degree, you make sure you label that 30 degree in your diagram, so that teacher know that, okay, how do you derive this 30 degree? Where you measure it from? So that's why if your answer has degree, you must label it in your diagram. Yeah, so mainly these are the 4 checklists. Done. Okay, so I shall move on. Are you all done noting everything here? Once you're done copying, can you click the thumbs up reaction button to let me know? Oops, sorry, people. I think I'll overrun a little bit. Yeah, I think I'll overrun like maybe 15 minutes. Yeah. Because today is my first and last time seeing you, so I need to finish everything. Okay, so I shall move on. Okay, so moving on to the next question. This question over here. So they are asking, okay, can you quickly do part A? Very easy, 1 mark only. Even though it's like 2 parts. Yep, you do now. Very easy. Can you tell me what's the answer? Keyword is, if you read the question, constant speed. So constant speed, what's the resultant force? Immediately can fill in, right? So class, what's the answer? Quick, you all answer me faster, then I can end the lesson earlier. Yeah, then don't need to hold your back so much. Yep, very good. So constant speed means resultant force 0, because we went through just now, right? You're not accelerating. Not accelerating means no resultant force. Next, if you want your overall force to be 0, how much should your friction be? So friction is like opposing direction. So how much should your friction be? Your friction should also be 17,000, right? Must be the same value, so that they will balance out and become 0. So yep, friction should be 17,000. Okay, right? Okay, so I shall move on. Done copying the answer? If done, can you click the thumbs up button so that I can scroll down? Are you done? If done, thumbs up. So moving on to the next part, part B. So they said that the graph show the acceleration, and they ask you to calculate the weight of the empty bus. And this is the time that I'm going to show you this L-shaped thing. Just now remember I told you a lot of calculation question, if you use the L shape, you can solve it. This is the time that I can demo it to you, which is this time round, since we are looking at weight, it means we are looking at vertical forces. So this time round, you can actually, let me see. Oh wait, but the bus is moving horizontally. Okay, so that means since the bus is moving to the right, we will take rightwards as positive. Yeah, so remember the blank that you need to fill in? So you always fill in the blank based on the direction they move. So this time around is rightwards as positive. Then now, let me demo to you how to use this L-shaped method. Based on the notes in front, if you flip your notes in front, you will see that below FR, I'll write MA. On the right, it will be, this time around, it will be the forward force, right? So that's why it would be the force by the passengers pushing. Then you all know that there is the resistive force, right? Because just now we mentioned that there is like friction. So there is frictional force. That's why you see, I'm saying that on the right side is always based on the free body diagram. Below FR, you write in the formula, which is MA. Then now we sub in the value. So in this case, do you know what should the force from the passengers be? If I want to calculate an acceleration and stuff, so correct, you should sub in as 20,000. Yep, so you should look at 20,000 because only with 20,000, it then start to accelerate, right? So at this point, since there is acceleration, then I need to calculate ma. Because if you choose 17, right, my A is 0. If my A is 0, wouldn't the whole thing become 0? Then cannot calculate now. Yeah, that's why you should choose 20,000. Yep, so then next is friction. Friction, take note, this is one of the common point that like a lot of students like unaware of. Need to know that friction won't change when speed change. Okay, so friction remains the same when speed change. Why? Because friction depends on, not speed, friction depends on the roughness of the surface and also the weight of the object, so-called downward pressing force. So usually when you solve for the friction in part A, you can use it for part B, C, D, E, F. You can use it for all the way. Because usually for this topic is that, they will change the speed and acceleration. But as I mentioned, friction doesn't depend on speed. Friction depends on roughness of surface and how hard you press down. Yep, so that's why if your speed change, no matter how the dynamics question change the speed, your friction is the same. So you can keep using the same frictional force from part A, you use all the way for B, C, D, E. So now, what's the value for the friction that you had from above? 17,000. So what is the mass? So you read the question above. Did they mention mass? Oh, no, they didn't, because you are supposed to solve for weight. Okay, so mass is unknown. Next, what is the acceleration? So this time round, they mentioned the acceleration is here, right? 1.5. All right, can see because we are talking about 20 ma. 20 is 1.5. Yep, so I sub in A as 1.5. 20, I continue copy down. Wait, actually this one can solve it, right? 20,000 minus 17,000 is 3,000. Yep, then you solve for M. Oops, I no space. I continue on top here. Yep, so solve for M. What's the value for your mass? Correct, 2,000 kg. Then now can you find weight? Do you know what formula to use? And then can go and solve it out. What's the weight? This time around, can we standardize? Everyone, we use G as 10 can. Okay, so we take G as 10 to standardize for this question. So for those online, in the end, what's your final answer? For those online, do you manage to get 20,000? If you can get 20,000 and can move on, can you click the thumbs up button to let me know? Then I'll move on to the next question. So should be done, right? I move on. Okay, so moving on to the next part. which is over here, part C. Describe one force acting on the bus that is not shown in the diagram in figure 7.1. Okay, so can you take a look at 7.5, 7.1? Which force is missing? What did they not label? We have weight, we have pushing force, we have the friction just now, right? What else is missing? Yes, very good. The normal contact force, right? Isn't this missing? Yep, so let's write it in. So describe one force. Okay, it's not state, it's describe. Okay, so we need to elaborate a little bit. Okay, so let's write down that is the normal contact force, or if you also use the word reaction force, also can. And this time around, maybe can be more specific, because you describe. So the force is by who, on who? Yes, very good. Yep, and that for this force, because it's 2 marks, maybe you need to further elaborate. So not only you have a normal contact force by ground upwards on wheel, there is also yes, correct. So you also have the reverse, right? Yep. So there is a normal contact force by opposite wheel on ground, which forms what is it called? Correct. Action, reaction, force. Done. So this will be the answer, lor. So it's like you must look at the mark allocation also to see how much you need to write. Okay, so I shall move on. You're done copying. One done copying. Can you click the thumbs up reaction button to let me know? Just to check, because there are some students that just join in, like Emma and Mesma. If you all need the lesson materials, you let me know, then I can send it to you. Done, right? Okay, so I shall move on. If you are not done, can you take a screenshot? Okay, then for those of you who are done, can you do question 8A now? Do 8A now. Do question 8A now. The next question, part A. Okay, so for part A, what are your answers? Yes, it's tension and weight. Then next is for your tension and weight, how long should the lines be? Like equal length or what? Yes, equal length. So meaning you just draw the tension on the string upwards and weight from the center downwards. Try to draw around the same length will do. Yeah, so this will be the answer. Okay. Emma, I just sent it to you by Zoom chat. Can you receive it? Okay, so moving on to part B. Explain using Newton's law of motion why the string is vertical even though the car is moving. So now if they ask you, in terms of Newton's law, you need to choose the law, right? So which law do you think is suitable for this question? Correct. You should use the first law. Why? Yes, correct. Newton first law. Okay, so meaning is that for Newton's first law, what is it related to? So which keyword in the question signal to you that, hinting to you that is actually a Newton's first law question? So this is string vertical at t equals to 30. So you look at t equals to 30 seconds here. Yes, why acceleration 0? Oh, you jump a bit far here. So from Newton's first law, how do you tell that acceleration is 0? So there's a missing gap. Anyone knows? Cause yes, correct. Can you see the velocity for section CD here, where the question is asking? Cause you see, the question is asking for 30 seconds. And at 30 seconds, it's horizontal. That means your velocity is constant. So must mention that velocity is constant. That's why acceleration is 0. Then in this case, This means that you are traveling at constant speed. So constant speed means you can link it to Newton's first law. Okay? So actually, wait, let me modify it. Should be like that. Okay, N1L means Newton's first law. Okay, so based on the graph, we can see that velocity is constant. That means Newton's first law. Then velocity constant, you can link it to acceleration zero. Acceleration zero, you can link it to the formula, right? Which is the F equals ma. Then here, you can also link to another law. Which law is it related to? The formula. Newton's second law. So actually for this question, cause you have to look at the mark allocation also. If it is 2 marks, you have to say 2 law. If it is 1 mark, you state 1 law. So can you all follow and also write this down? So need to look at the mark allocation. 2 marks equals 2 laws to write. 1 mark be 1 law to write. Yeah, so can you all label it in? So this is a hint. So in your WA, remember to like for the mark allocation. Because the mark will tell you how many laws to write. So this question is 2 laws to write. That's why you must write both Newton first and second law. Yep. So in this case, mainly need to mention about the resultant force is which is MA, where the resultant force here is actually the forces are balanced. Can you follow and copy it down? In case you can't see the word clearly at the bottom, I'm trying to say that for the resultant force, the forces are balanced. Let me try to drag the words higher a bit. Okay, yep, like that, clearer. So you need to mention that because the forces are balanced, that's why in the end, based on Newton's second law, force zero means acceleration zero. Done. So I'll leave it to you to write it out as proper sentence. These are the key points. Once you include all the key points, then your answer will be correct already. So just phrase it out in proper paragraphs then. Okay, so I shall move on to the next question. Can you do part C now? Yeah, so once we finish the worksheet, then I'll end the class. Yeah, do part C now. Do part C. So what happened at time equals to 5 seconds? What happened to the vehicle? It's accelerating, correct? So if it is accelerating, then same thing, you see, part D, they ask you to link to Newton's law of motion again. So which law can we link it to? Second. Okay, so if you feel that it's second law, okay, so because YA, you got acceleration, that's why you have like a resultant force, right? But the resultant force is just meaning upward and downward, mah. So if you say that there's like force, you mean the object will drop down or float up, is it? So what will happen for the ball? The ball is not dropping up or moving up. It's not moving up or down, right? The ball should be moving left or right, correct? So in this case, which way do you all think the ball will swing? Should it swing left or should it swing right? Then for those online, you want to have to contribute also? What do you think is the answer? Is it point swing left or swing right? Yep, Justin and Xingyi correct. Very good. It's swing left. So this is the answer. Why? Because as you are accelerating, is that this is actually linked to, do you know which concept is it related to? Yeah, first law mainly called inertia, yes. Yeah, because by right, the object want to move at constant speed. But you accelerate, that means your physical vehicle is faster in front. But my object want to stay at that same slow speed. That's why my object want to remain behind. That's why the object will swing towards the left. Yep, so for part B, we can explain now. Using Newton's law of motion, explain your answer. So first thing to explain is that you must mention that because at 5 seconds, it's accelerating. Then now that you know that it's accelerating, you link it to inertia. So due to the inertia, what happened to this mass over here? What they call it as mass. So what would the mass be? So the mass will try to Can you check inertia or Newton's first law? Remain, correct. In its state of, so if you check your notes, it's remain in state of rest or motion. Yeah, so you want to remain the same even though the velocity increases. Then done, that's all. So you just piece up all the words together, you write as a proper sentence, this will be the correct answer already. So the key points are all in there already. Okay, so before you all go off, I will be sharing with you the answer key also, which you can download to check your answers after you are done practicing. Okay, but before that, would you mind help me to like fill in this feedback form? Yeah, since we spare out time to like conduct this lesson. We spend so much time, you see 2 hours to conduct the lesson. Can I just get your few seconds to help me fill in this feedback form? Yeah, so that we know in future when Overmark continue to have more of such free lessons, we know how to like better cater to your needs. Yeah, so can you drop us the feedback? Can scan, right? Yeah, so can you help to feedback so that we can know how to make the lessons even better? Yeah, so hope that you all benefit from the lesson today. If any of you have any questions, you can stay behind and I can address the questions and your doubts for you at the end of the lesson. Oh, thank you, Justin. After you all fill in the feedback form, then I will show you the QR code for the answer key. Yeah, so I'll recommend that you all finish up the remaining questions that we didn't get to practice during lesson. Yeah, then you can check with the answer key. Because science and math are similar. You need to practice, then can do well. Yeah, also go and practice lah, since the answer key is provided. Okay, so the left side one would be the answer key. Yep, so can you all scan and like save it properly? Yep, so you save it somewhere. So the left side here is the answer key. Yep, then once you are done with the feedback form and done downloading the answer key, you can go off already then. Yep, so that's all for today. So signing off then. Yep, so I'm Miss Felicia. Yep, so signing off. Bye-bye.